Mars, and it's been kind of a busy week around here this week. We've been doing a lot of looking, we've been digging and scooping, we've been dumping and shaking and sifting, we've started baking. We're going to start sniffing real soon and also doing some tasting. And to tell us more about these sensory experiences today are Peter Smith, the principal investigator of the mission from the University of Arizona, Tom Pike, science team member for the optical microscope from Imperial College London, Mark Lemon, stereo surface imager lead scientist from Texas A&M University, and Milton Reno, science team member for atmosphere from the University of Michigan. And Peter, why don't you lead off our discussion today?
Thank you, Sarah. Our last televised press conference was marking the end of our characterization period. That's the time we chose to test our instruments and to do our first touches of the soil and actually kind of get our calibrations all done so that we're ready for our science phase. Today is our first science phase press conference, and so we have a lot to report. The most wonderful news I can give you right away is that we have samples from the surface inside of two of our instruments, the microscope and the TIGA. And today we'll hear about the microscope examination, but the TIGA information will be coming shortly after. Not today, but next week. Just to recap, to get back to the big picture of this mission, our mission was inspired by the data returned from Odyssey spacecraft, and the Odyssey scientists, including our own William Boynton, told us that there was ice near the surface surrounding the polar caps. And so the Phoenix mission is specially designed to try and understand what is going on inside of this ice. This is important because on Earth, polar regions preserve traces of climate change and even signs of preserve signs of life and organic materials. So this is a really key place to look on Mars to see if the same thing is true there. On the Earth, we use very sophisticated instruments to do these experiments, and we brought similar sophisticated instruments with us to Mars to do this analysis. The orbiters have been very helpful in the process of getting us to Mars. We've had the Mars Global Surveyor and the Odyssey that have provided data sets that we use to choose our landing site. But it wasn't until we had the Mars Reconnaissance Orbiter with its high-resolution camera that we learned we had to avoid rocks. And we were very successful in avoiding rocks, as you can see in the pictures that Mark Lemon will show just after this. And this has been really useful for us because some of the regions in the polar, some of the areas in the polar region are extremely rocky. We also use our orbiters for communications, and really during our entry, descent, landing, we got signals back from both Mars Reconnaissance Orbiter and from Odyssey, and also from Mars Express. So the orbiters have been very useful in communicating our signals back to Earth, and in fact we're getting so much data back that we're getting about twice the data volume that we're told to expect, and this has caused some consternation among our team because you have to write sequences for all the data gathering that we do with our instruments, and these sequences take a fair amount of time. They have to be checked and rechecked, and so our team, who are working on the difficult Mars time schedule, which of course started at the worst possible time at night shift and has now progressed to graveyard shift, has left the team a little stressed and tired. So if you see some tired people around the building, you know that they're probably on Mars time. So for the first time since Viking, we have instruments that have samples from the Martian soil inside and are ready to start analysis. We are, excuse me, our results from these analyses are going to be used to inspire future missions that will come to Mars and hopefully take over where we leave off, because we're bound to raise lots of questions. Okay, the next thing I want to talk about is digging into the Martian soil, and this has been something we've been doing for the last week or so, and digging in soil has been, of course, one of our key activities because we're trying to find an ice layer, which we're told exists. We see a hard surface underneath the lander, and now as we dig into the soil, we see a hard, bright surface right within just a few inches of the upper layer. And if I can show the first picture, that is our first dig test into the soil, and then next to it you can see flashing on and off is where we've done our sampling. So the first dig test actually disclosed a bright surface just a few inches down, 2.5 inches, and so we've taken our samples right next to that, and we've delivered those samples to our TIGA instrument and our microscopic instrument. But there's still some debate about that bright material, so in the next slide we can see what we've done very recently is to try and dig a little deeper in both of these areas, and we see the exposed ice. So this is, I'm sorry, this is the second slide, which shows the same two locations as it was sampled a few days ago. Now the latest picture will be the next one that just came down today, and that's not there it is. So that's the exposed ice. It's just as we've seen it today as we dug a little deeper into these two trenches. And now, not everybody is sure that this is ice, so there's been some debate within our team. And the debate centers around perhaps there's a salt layer above the ice, which would be very bright and white also. So we don't want to discount that possibility. And some people hold on to this theory and some don't. So we've had a fairly intense debate among the team whether that's ice or salt, but everybody believes there's ice near the surface. Whether that's it or not is the question. The other question is this thick ice that goes down deep beneath the surface, or perhaps this is a thin layer and we'll be able to scrape through it. So scraping with our tungsten carbide scrapers on the scoop is really a high priority for us. The next topic is delivery to the TIGA instrument, and my next slide shows the first delivery to TIGA, which was a big scoop full of material dropped onto the cell, and it stuck and would not go through the screen. And you can see it's laying there on top of the open doors of the TIGA instrument. The TIGA oven showed no response. We tried using our little shaker device day after day for 4 days, and after 7 shakes, if I can show the next slide, yesterday we were successful, and this is a picture showing that the material has slid down over the screen, sort of like going over a cheese grater, and some of the material has gone inside and has filled the oven. And we sent the commands for the first operation last night, but we don't have our data back yet, so we can't report on any results today. This will be coming early next week. So this is a very exciting time for us. We find the soil is very clumpy, it's very sticky. It's an unusual soil, not at all like the types of soils we've used in our tests, which work just fine with all the instruments. And so we've developed another method of collecting samples, and that is to tilt the scoop a little bit and then vibrate it with a little power tool we have on the scoop. So it vibrates it a little and it shakes some soil down, and it kind of rains down onto the screen or onto the delivery port. And we think this is the method we're going to be using from now on, and we'll hear more about that. So next week, pay attention, we'll have results from TIGA, and we'll be delivering samples to our wet chemistry cells. And to show off to introduce my next speaker, I have a wonderful